Welcome to Own Your Zone podcast, where we feature venture capitalists, innovators, angels, and other investors who create positive impact globally. Now, let's get started with the show.
Hi, I'm JiNan Glasgow George, a patent attorney and founder of Neo IP. We're a law firm that helps clients maximize their return on investment for patent assets. I'm also host of this show where we feature innovators, venture capitalists, and innovation-focused private equity funds, angels, other early-stage investors. Let's have a word from our sponsor. This episode brought to you by Neo IP, where we help companies increase their valuation and protect their business through strategic business planning and IP protection. We provide corporate and legal services that helps companies manage risk, develop portfolios, and monetize their IP assets. We believe intellectual property is a valuable business asset with exceptional potential. Neo IP is here to protect that. Learn more about Neo IP at neoipassets.com. If you'd like to talk more about your business needs, email us, admin@neoipassets.com. I have here with me today Joe Weinman. He's a famous author of Cloudonomics, among other books, and a renowned expert in cloud and edge computing. Welcome, Joe. How are you?
I am great. So happy to be here with you, JiNan.
Thank you. Thanks for your time. You're famous for your Cloudonomics book, obviously. What motivated you to write that?
Well, when I was at Bell Labs and then AT&T, I used to do all the corporate briefings, and I would use cryptic comments like I would say, the cloud can cost you less, even if it costs you more. And what I was talking about was the difference between unit cost and total cost. But I sort of realized that a lot of people in the audience were sort of nodding their heads, but had no idea what I was saying. So I didn't want to make it too difficult. So I explained what I meant, but then I started writing white papers to describe the economics of cloud computing. And I eventually had a whole bunch of white papers, and I got invited to be sort of interviewed for a John Wiley book. And they, needed my bio and a photo and an authorization for me to use that. And so I was like, hey, by the way, do you have any interest in a cloud computing book? So they were like, tell us more. And, the rest is history, as they say. And then I was doing a lot of talks around cloud computing, economics, and strategy. And I had like 30 equation slides and one strategy slide. And I noticed that people's eyes started glazing over whenever I put an equation up. But when I started talking about strategy, all of a sudden they woke back up again. So I'm not a complete idiot. I eventually went to 2 strategy slides and 29 equation slides, and then 3 and 28. And then eventually I basically had a whole cloud computing strategy deck. And again, it hit me, hey, there's a book in here, because I have so many great examples and I've kind of worked out the science of what it is. And so that led to Digital Disciplines. So by the way, I'm sure you found this, JiNan, since I know you're an author and your book is amazing. But all the stuff they tell you, that you're supposed to do when you're a budding author, and I think most people maybe always had the idea that they would write a book. They're like, you have to get an agent, you have to do this, be prepared for rejection, send out, J.K. Rowling sent out, 20,000 letters, and got 19,999 no's before she ever got the acceptance. And now look at her, she's a billionaire. None of that stuff actually is the way it worked, at least for me. So, okay. So it was just more a work of passion, because I'd worked out all this, I think, groundbreaking stuff. And I just wanted to share it with people.
Yeah, it's awesome. And you're such a great speaker too. You were recently featured at the recent Intelligent Infrastructure Conference in Austin, Texas. What did you talk about, and how was it received?
Well, there were not many equations, so not too many people fell asleep, but the rest seemed to like it. I talked about a number of things. So one of the big things that's occurred, which I predicted literally 10 years ago in writing in the book Cloudonomics, that was the rise of the edge. And I didn't call it edge because that term wasn't in use yet, but I'd worked out the math of the advantages and disadvantages of centralization and consolidation versus decentralization and dispersion. And, it's a matter of trade-offs, right? So there is no perfect solution any more than there's a perfect solution for what vehicle to drive. Well, if you have a family of 5 and you're going skiing, maybe an SUV is good. If it's just you and it's summertime, maybe a smaller 2-seater convertible is good. If you're, moving someone's house, then a tractor trailer might be good. So to say, all IT will move to the cloud, or all IT will move to the edge, or all IT belongs in the cloud, not a private data center. I don't believe any of that is true. I don't think there's any other industry where there's that sort of purity. People own their own homes or lease apartments, and then they also have short-term rentals in hotels. They, own or lease cars, so it's a dedicated resource, but they also rent cars and take taxis. So the idea of, private ownership of resources when utilization is relatively high, what that does is it converts even a high unit cost into a relatively low total cost of ownership. Whereas if demand is very intermittent and or there are performance differentials, then it certainly makes sense to use a public cloud on a pay-per-use basis. The same way that if you live somewhere, it probably makes sense to have a house, say. But conversely, if you're only going to be in a town one day for your entire life, it might be cheaper to get a hotel room than to build a house on the off chance that you show up there. So the centralization versus decentralization argument is also kind of interesting mathematically because you're dealing with a number of trade-offs. So one of them is the idea of statistical multiplexing intermittent demand. So I may only be in a town for 2 days my entire life, but a hotel can be very profitable if, after I check out, someone else checks in, and after they check out, somebody else checks in. And so that statistical multiplexing effect, when I'm dealing with lots of variable demands, actually takes hold at relatively low levels. I get massive benefits, even for, 5, 10, or 20 demands, and then they start to peter out, right? So, the idea having 1 million, hotel customers versus 2 million, their yield or their utilization is going to be, right around 100% regardless. And this is all just simple statistics. There's, nothing super complicated. It's intuitively clear, but it's also mathematically provable. So the other thing that people talk about when they think about edge versus cloud is the idea of latency reduction. And that certainly exists. What you have to do, though, is understand particular scenarios. So one scenario that people talk about, for example, is the idea of remote surgery, and that something like 5G, which has extremely low latencies, will make, remote surgery possible. Well, it sort of depends on what you're talking about, right? Because the idea that going from 20 milliseconds to 5 milliseconds or under, that certainly does have a, meaningful effect. But if the idea is that I'm a doctor sitting in the New York City metro area, and there's someone in a poor village in, I don't know, Argentina or Mongolia or something that needs remote surgery, and that 5G will fix all that, that doesn't really make much sense to me. Because first of all, it doesn't account for global WAN latency, which can be more like 160 milliseconds. And secondly, it assumes that a very poor village with dirt roads, with, goats walking on the roads, somehow has a great 5G infrastructure and has amazing, telesurgery equipment sitting there just on the off chance that one of the villagers needs the particular operation that this equipment can do. So, people overhype those kinds of things.
Yeah.
And it's unfortunate because there really are good use cases. So a really good use case is where I have low total latency, not just low latency across the radio access network, and I have sufficient density and a sufficiently vibrant economy to make edge deployments economically worthwhile. So smart cities or smart corridors, busy portions of highways are great examples of where that makes sense, because it makes sense to deploy a wireless network connectivity infrastructure. And there are lots of applications that one can think of that require just very intermittent connectivity and also extremely low latency and processing at the edge, because I'm doing something, and people usually refer to that as the OODA loop, where the idea is that I am observing, I'm orienting, I'm deciding, and I'm acting. And so kind of, the basic idea is, think about like a karate battle or something where, I see something coming and I realize, okay, he's trying to hit me, and I put my arm up and block it. So that's a very short cycle between, figuring out what's going on, making a decision, and then acting. And of course, in smart cities, we have that, all over, particularly as we think about vehicle to vehicle or vehicle to roadside infrastructure types of communications, where, or another one is vehicle to pedestrian or vehicle to bicyclist, where you're using a combination of onboard sensors, like, LiDAR, that are busy detecting what's going on around you, but that's not always enough. And some of those images can be blocked if there's fog or rain or what have you. So certainly augmenting that with some connectivity, where basically a car says, hey, I am right here, basically in front of number 37 Main Street, and I'm heading westbound. And it looks like you're in front of number 38 Main Street heading eastbound, but it also looks like you're straying into my lane, and we've got like 80 milliseconds to figure out what to do. There's a case where being able to do rapid connectivity and processing at the edge, which may require global optimization as well, right? So picture that there's the car coming straight at me, there's a pedestrian on the left, there's a bicyclist on the right, there's a narrow opening of opportunity between two parked cars, right? That's some pretty complex decision-making that needs to be done. And so there's a case where there's actually, an economic benefit, and beyond economic benefit, we're talking about human life. And there's enough user density to make it economical to deploy infrastructure. And there really is, the sort of computational ability to make all that happen. So
these use cases are great. Your analogies are really helpful, because it does seem like for a while, everything was getting cloud washed. Everything was cloud, cloud, cloud. And now we are hearing more edge, edge, edge. Is there any true edge out there? What companies are you looking at? What should we be looking for as investors, and who are the innovators?
Well, to take your question in two parts, first of all, yes, you're right. The balance switched from, nobody's going to, go to a bookseller for their compute. What a crazy idea. To, oh my God, everyone is going to use public cloud and all IT will move to the cloud. And that's like, nobody's going to stay in a hotel and then everyone's going to stay in a hotel. No, like people stay in a hotel when it makes sense, and they, sleep in a camper when that makes sense, and they stay in their house or apartment when that makes sense. So
we never sleep in campers, Joe. No camping.
I don't, but I know people do, and people live there. So so one company that I am affiliated with obviously is EdgeX, and EdgeX, the reason that I'm affiliated with them is basically because they have the super cool technology that they've developed. So one is obviously it's edge computing, but the other thing is that they've created with, I don't know how technical your audience wants to get on this stuff, but basically a distributed data replication architecture so that all the nodes at the edge are either a master or a replica of data, and everything is kept in sync. So what that means is that data that I may need, and again, think about a smart city, where the other cars or entities like people and bicyclists are, the digital signage, the state of that digital signage, where parking spaces are, where trash receptacles, where snow plows, et cetera, traffic light timing and phasing, all of those things, are all replicated appropriately in a way that balances out cost with reliability and timeliness of access. So that's on the data side. On the processing side, I think the best analogy is a sip of wine, which is probably one of my favorite hobbies. And sip is probably not one of my favorite levels of consumption, but let's take that for a second. So if you are throwing, let's say, I don't know, a wedding or a giant party or other celebration, and you want a lot of wine, it probably makes sense to buy a giant cask of wine, right? And you have all that wine, but you're going to use it and you're getting it, without the overhead of bottles and bottling and labels and things like that. Mm-hmm. If I want, less wine than that, I might get a case, or I might get a bottle, or I might get a glass. And if all I want is a sip of wine, I might put it in a taste van or a teaspoon. Okay, so that's, everyone can understand that, right?
Yeah.
So, the point is that you want to use or ingest quantity that makes sense given the level of your demand. Now, before virtualization technology came along, you ran these giant monolithic applications on giant mainframes. Yeah. And that's sort of the equivalent of a cask of wine. And then gradually, as technology has evolved, people figured out how to get closer to cases and bottles and sips. So, virtualization led to the ability to take a single server and chop it up into multiple virtual machines and run securely, workloads in those VMs. And that's a great idea if I have sort of, not a massive amount of processing to do, but I want to keep something alive, like, a web server or a database server or something that runs in the background or what have you. And then people came up with containers, which was even a, smaller sized entity and had some additional benefits to it as well. But the ultimate, which some of the cloud providers came up with originally, was the idea of cloud functions or microservices. And that is the idea really of just a tablespoon or teaspoon of wine rather than the entire cask. And so, a microservice or function does basically something that's pretty well defined. It is able to be rapidly invoked and rapidly turned off. So it's, grab a teaspoon, sip the wine, throw the teaspoon away or into the dishwasher or whatever. And so the same thing happens with microservices, where let's say you want to validate that a credit card is actually a correct credit card, or double check that a particular address that someone enters is in the correct form for the postal service with, street spelled as ST instead of street, or the 4, digit zip +4, additional numbers. So, those are microservices. And the idea behind the EdgeX technology is, rather than running dedicated servers, you are running these microservices in secure sandboxes. And what that means is that if I, as a driver, I'm driving by and I want to know something like, where's the nearest parking space, I can just quickly launch the parking space microservice, figure out where it is based on my location, and then return that result. It's 2 blocks away and to the right, and then get rid of the microservice because I don't need it anymore.
Yeah.
So if you remember earlier on, I talked about statistical multiplexing effects, that, having just a teaspoon, or access to a teaspoon of wine or a microservice at every edge node makes a lot more sense for virtually all applications that you can imagine for smart cities than it does to say that, at the extreme, hey, I might be driving through, through Madison, Wisconsin, some point in my future, and I may want to know something about parking spaces there. Therefore, what I'm going to do is I'm going to, spend my money to deploy a server at the edge, or thousands of servers at the edge, just for Joe Weinman to use on the off chance that I'm there, right? So that obviously doesn't make any sense.
Right.
And an obvious response to that is, well, you could run a server somewhere in your own data center or in the cloud to do that, and then remotely access it. And again, that's true for some applications, but for applications that must run at the edge, for a variety of reasons, and I talked about latency, but another one is simply the magnitude of the data that is being collected at the edge,
right.
especially with, video surveillance or just video capture, say in a retail environment, seeing where shoppers tend to migrate once they come into the store based on specific information that's on a digital sign. Like, do they respond more to, Brunello on sale to the left or Amarone on sale to the right? You can do those kind of A/B experiments, but it requires video processing. So, so the point is that, even if latency isn't a concern, I don't want to ship all that data, up somewhere into the cloud and pay for that network transport in or out, if I can just process it at the edge and do my, machine learning, AI, decision making, whatever it may be, right at the edge without having to basically, ship that data. And people, think that bits don't weigh anything, which is mostly true, but it costs money to ship them, and it costs more money to ship them farther. Like, we think that, things are distance insensitive, but obviously if everything has to be shipped 5,000 miles versus it only needs to be shipped an inch, I need to build out a lot less network capacity, and therefore my network costs are going to be lower. So, there is a real cost that is relevant that people tend not to think about.
Yeah, this makes sense. So EdgeX is a company to watch in edge computing. We'll keep an eye out for EdgeX and their offerings. When can we expect some of this intelligent infrastructure to be installed? I think we're seeing it in bits and pieces in North Carolina and Ohio and Texas. When do you imagine that's really rolling out?
Well, I think it's like saying, when will smartphones roll out or something like that back in 1980, in the sense that, it's an avalanche, and, the snowball starts rolling and then it just gathers steam. And, to your point, yes, there's, everyone's excited about it. People are doing deployments. Some cities are, let's say, more forward-looking than others. The Infrastructure Investment and Jobs Act will help, accelerate that. I think, as various municipalities and states and so forth take advantage of those funds to go ahead and pursue different initiatives. But it's just going to continue, right? It's the next 1,000 years will be, edge computing, the same way that if I started in 2007 or so, it's safe to say the next 1,000 years will be cloud computing. So it's ramping up exponentially. Approaches, standards, technologies, algorithms are being defined. Patents are being awarded, which I know you're very familiar with, since
it is true.
Your company has done a number of the leading edge patents in this field. So it's just going to continue to snowball, and soon we won't think about it any more than we used to think about. Wow, there's this thing called AOL, and you use your phone to get access to bulletin boards and to send this thing called email. And, now it's just, we just do stuff and we're like, hey, you need to do a Zoom at, 4 p.m. Okay, sure. That works for me. Let me just use my, Calendly to set it up with you, and just I'll send you a confirmation via Gmail. Right. Nobody thinks about it. It just happens. And so
we have time to get a glass of wine, maybe in between now and then, I think.
Yes, there's still a need for wine to be real and not virtual for some reason. I don't know.
You're obviously very creative with the stories and analogies, and we can see that you're a musician. Tell us a little bit about some of your musical interests. What do you like?
You mean who do I like to listen to?
Yeah.
Well, I have a broad range. It would take a long time. I love everything from Bach to Nine Inch Nails. In fact, I was just seeing that Nine Inch Nails is in concert again after a few year hiatus. But I love jazz rock, blues, sort of a little bit of industrial, and sort of Baroque classical, not so much the symphonic stuff after that. But everyone has their own likes and dislikes, obviously.
For sure. Well, you're very obviously brilliant in all things compute, edge compute, cloud computing, and so talented. So we hope to welcome you back on this show again in the future, Joe. Where can people find you if they wanted to have you speak at a conference?
Just Google Joe Weinman, and everything is Joe Weinman. Joe Weinman on LinkedIn, Joe Weinman at Gmail, Joe Weinman on WeChat, Joe Weinman on Twitter. It helps me keep it straight. I keep it simple for myself, not for anybody else.
This has been awesome. Thanks for translating so much of this technology for us today, Joe. It's been a joy to have you on the show. Thanks.
It's been my pleasure to be on it. Thank you.
Thank you.
Thank you for listening to the Own Your Zone podcast. We'll see you again next time, and be sure to click subscribe to get future episodes.